Hi students, good evening, welcome back. Yes, hope you all can hear me properly. If you remember in the last class, in the last classes, we were doing the chapter chemical bonding, correct? So we were on with the chemical bonding and we have tried to understand so far how the hybridization works and what is the information we get from the hybridization. It's all related, what it's all related to the geometry of the molecule. That is what we are understanding using the hybridization concept, correct? So today what we are going to do is based on the hybridization concepts, and not only based on the hybridization concept, based on the other concepts also, we will try to solve few questions. And we are going to start with the hybridization questions itself, okay? Because as I told you, they are very important with respect to the competitive exams. And today I have tried to pick some of the previous year question paper questions only, okay? So let us try to solve one by one. So these are the things what we have done in our last class, correct, with respect to all the hybridizations. And if you remember, I had also asked you the question on the IF7 hybridization. I hope you all have got the IF7 hybridization. Apart from that, I also hope that you have understood what are the bond angles. Okay, that is also very important. One thing I want to mention over here is when we have the Sp3 D3 hybridization. Okay, so it is nothing but the pentagonal bipyramidal structure. Here, the d orbitals in the Sp3 hybridization, Sp3 D3 hybridization, Sp3 D3 hybridization, the three d orbitals involved are dxy, dyz, and dzx. Okay, because we have come across the Dsp2 hybridization. Okay, there we come across dx square minus y square orbital. Okay, we come across Sp3 D hybridization. There we come across the dz square dz square orbital. When we come across Sp3 D2 hybridization, here we come across the dz square and dx square minus y square orbital. But when we come across the Sp3 D3 hybridization, the three d orbitals involved are dxy, yz, and dzx orbitals. Okay, right. So we'll move on towards the questions. And the first question we are going to come across here is, we have already solved few questions. Okay, so the first question what we will come across is, in which of the following molecules are ions, all bonds are not equal? And as I always do, I always give you 60 seconds time to solve each question, and your time starts now. You have 60 seconds to solve the question. Okay, your time starts now. So the question reads, in which of the following molecules, all bonds are not equal? Yes, good evening to everyone. Good evening. Yes, you have 60 seconds. Start solving. Right. Here, apart from solving the questions, if you can also find out hybridization of each molecule, that will be really helpful. Okay, so that it will be practice also for you to find out the hybridization. So let's utilize the 60 seconds in that way. Okay, so let's utilize the 60 seconds in that way. Also practice the problems, the hybridization of each molecules. Okay, so I've given you enough time. Start solving one by one. Okay, and please be quick. Somebody has already answered me. Prabhakar has already answered. The answer is C. Very good. Okay, already started answering. So one of your friends are telling the option is what? The option is C over here. Anyway, we will go. We are going to check it. Okay, that should not be an issue. We will check it one by one. Okay. You can also share the video link with your friends, so even they can go through the classes. Okay, It will be helpful for them. Right. So let us start with the first example. Okay. So the first example we are coming across here is the Sf4 molecule, correct? The Sf4 molecule. See, it's very important to understand first thing the Levi-Strauss structure. It is very important. Okay. So if we understand the Levi-Strauss structure, I'll tell you the basic idea how to solve them. Okay. Obviously, again, there are so many different techniques to solve it. I'm not telling you should not do that, but there are different techniques. What we will do is we will go step by step and we will try to understand how to solve these examples. Okay. Now, when you go to the Sf4 molecule, remember sulfur belongs to the oxygen group, correct? So if I want to write the Levi-Strauss structure, I clearly understand here sulfur with the two lone pair of electrons and two single electrons, correct? So this is how exactly is the Levi-Strauss structure. So how many fluorides are linked with that? 4, correct? So I am going to link one over here and then one over here, and then let me say one over here and then one over here. So what do I really understand here is there are 4 sigma bonds, and let us not forget that there is also one lone pair of electrons over here, correct? So what should be the hybridization? That also answer I want. So what should be the hybridization? Be quick. What should be the hybridization of this particular molecule? So if you check the hybridization of this particular molecule, so let me say here it is S, and let me say here it is P, and let me say here it is P, and then let me say here it is P, and again you have a lone pair electrons here, correct? If you have a lone pair of electrons, obviously I am supposed to consider them for the hybridization. And I think I've already told you why are we supposed to consider the hybridization, or I mean the lone pair of electrons into the hybridization, correct? So can anyone give me what is the reason why are we considering the lone pair of electrons in the hybridization? Because they contribute to the structure, correct? So it's a very important point. So these are contributing to structure, correct? They are contributing to the structure, and hence we are considering. So what should be the hybridization over here? The hybridization for this guy should be Sp3 dehybridization, correct? He has to be my Sp3 dehybridization. Now, when you consider the silicon fluoride, so when you say silicon tetrafluoride here, so I understand silicon belongs to which family? It belongs to carbon family. So how many electrons it should be having on it? It should be having 4 electrons, correct? So if it is having a 4 electrons, then you have a F here, then you have an F here, then you have an F over here, then you have an F over here. So let me say it is having 4 sigma bonds. So if you say this is S and then P and then P and then P. So I clearly understand here the hybridization is what? The hybridization is Sp3 hybridization. Correct? The hybridization is Sp3 hybridization. Now, once you get the Sp3 hybridization, next we go for what? We go for the xenon tetrafluoride, correct? When you go for Xef4 molecule, one by one I will explain, okay? So when you go to Xef4, what is the Levi-Strauss structure over here? The Levi-Strauss structure over here is it is having 4 lone pair of electrons on him, correct? It is having 4 lone pair of electrons. So let me say this is how it is. Okay, these are the electrons on it. So now what I'm supposed to do now, I'm going to connect 4 fluorine atoms on it, correct? So let me say one fluorine is over here, one more fluorine is here, then you have a fluorine over here, then you have a fluorine over here, correct? Let us not forget there's an LP electron and there's an LP electron. So check the hybridization of this guy now. If you check the hybridization of this guy, then you have an S over here, then you have an S, then let me say, sorry, then you have a P over here, then let me say this is P, then this is P, then this has to be D, and this has to be D. Correct? So if this is the case, then the hybridization will be what here now? So here we understood the hybridization is Sp3 hybridization, but here the hybridization is going to be what? Sp3 D2 hybridization, correct? You find there are 4 sigma bonds with 2 lone pair of electrons, Sp3 D2. Okay. Now, similarly, when you go for the F4 minus molecule, that means B is there. Then it is having, see, how do we consider this guy? If we go to the excited state configuration, let us not forget that boron is having 1 electron here, 1 electron here, 1 electron here, but it is also having an empty orbital. Correct? It also has an empty orbital. So what exactly is happening over here? I understand one fluorine is linked here, one more fluorine is linked here, one more fluorine is linked here, and one fluoride ion has made a bonding here. I mean, it has donated its electron. It has donated its electron over here to make the fourth bond. So again, what will be the hybridization? Look at that. All the four orbitals are involved, correct? So here also you will find the hybridization is what? Hybridization is sp3 hybridization. Correct. So here also you will find that it is sp3 hybridization. Correct. So now we have to understand. So let us go to this example. So we have to now understand what are their individual structures. So again, that is very, very important. What are their individual structures? Okay, fine. So I hope you have understood, like using the Lewis-dot structure, using the Lewis-dot structure idea. Okay, how we identify how many lone pairs are there and how we identify how many sigma bonds are there. That is very, very important. Okay, so I hope you have got this one. So now let us try to understand their individual structures. Okay, now when you consider the Sf4 structure, as I told you, the hybridization was what here? It was sp3d. Here it was sp3. Here it was sp3 D2, and the last one was again sp3. Okay, now sp3 will show you tetrahedral structure, correct? sp3 is showing you tetrahedral structure. Tetrahedral structure. So that means what? So if I randomly say this is my silicon over here, so one fluoride will be here, and then I have one more fluorine here, then I have a fluorine over here, then I have a fluorine over here. So this is what? This is my tetrahedral structure. If I want to join this, I can easily join it. Okay, so this is my tetrahedral structure. Okay, tetrahedral silicon. So similar structure will be also present for what? Similar structure will be also present for the BF4 minus. So here what exactly happens? See, what are we trying to find? We are trying to find the bonds, correct? So in this case, all bonds are equal. Okay, so let us not forget that in this case, all bonds are equal. But when it comes to the XeF4, so let us try to understand how is the XeF4 structure. So XeF4 structure is exactly like this. So you will find there's a lobe over here. Okay, then you'll also find the lobe over here. Okay, then there is a fluorine atom here, then is a fluorine atom over here, then the fluorine atom is over here, then the fluorine atom you will find it over here. Okay, so just check this one. So this is exactly how the XeF4 molecule you will find. XeF4. Okay, so this is your XeF4 structure. So what will be the overall geometry here? Okay, the overall geometry you find over here is overall geometry. Okay, including the electrons, I'm telling you, including the electrons, the overall geometry is what? It is octahedral. But when you consider for the atoms, it's the, okay, when you consider just for the atoms, I'm not telling you that it has to be considered for the electrons also. When you consider for the atoms, the overall structure is what here? Can anyone tell me? Can anyone message me what is the overall structure? Please explain quickly. What should be the overall structure? Anyone? Yes, I'm just trying to look at the chat. Anyone? Overall geometry is octahedral, but when you see only the atoms, it is going to give me what? It is going to give me a square planar complex, correct? It is going to give me square planar complex. Okay, or a square planar geometry, I can say. Okay, so it is going to give me a square planar geometry. Now let us try to understand the Sf4 structure. Now it's very, very important. Okay, let us try to understand the Sf4 structure. Now when you observe the Sf4 structure, okay, when you try to understand the Sf4 structure, so yes, somebody is trying to message, I'm sorry, Sf4 structure. So sulfur sits over here. So let me say one fluorine is over here and another fluorine is over here. Then one fluorine sits over here and then one more fluorine sits over here. Then the lone pair of electrons. Okay. So what do I understand in the Sf4 structure is, what do I understand over here is, I clearly understand in the center, there are what? These are which kind of bonds? I think I've already explained you. These are your equatorial bonds, correct? So in the center part, what you find over here, these are your equatorial bonds. correct? So here you find there are your equatorial bonds, and on top and at the bottom, you will find that there are axial bonds, correct? So here you will find there are axial bonds. And I think in the last class only, I have made it very, very clear that my axial bonds are slightly longer compared to which bonds? Compared to the equatorial bonds. Axial bonds are slightly longer compared to what? Compared to the equatorial bonds. And that is the reason why here all bonds are not equal. All bonds are not equal. All bonds are not equal. So please make a note. The simple reason is what? The simple reason is axial bonds are not equal to equatorial bonds, because axial bonds are slightly longer compared to which bonds? Compared to the equatorial bonds. I hope the point is clear. Okay. Sf4. Right. So I hope there is no doubt in this question, and I'm going to move to the next question. Again, as I told you, most of these questions, all these questions are your past paper questions only. Okay, right. Let us go to the next one. Okay. The next question is what? The next question is the maximum number of 90-degree angles between bond pair of electrons is observed in. See, now the question is not between the lone pairs. Okay. So there are normally how many types of interactions? Three types of interactions. One is the lone pair interactions normally, which is a stronger interaction. Then you have a lone pair and bond pair interaction. I mean to say this is repulsion. Okay. Then the last one is what? Bond pair repulsion. Okay. Sorry. Bond pair and bond pair repulsion. Bond pair repulsion. Bond pair repulsion. So here the question is what? The question is how many angles are present between the bond pair of electrons. Okay, so the whole question is what? The whole question is bond pair of electrons. Now 90-degree angles. See, we have come across different hybridization. For example, if we say sp hybridization, the molecule is linear, correct? And linear, the bond angle is what? Bond angle is 180-degree. If we come across sp2, it is trigonal planar. I think I have given you all these structures. It is trigonal planar structure. Correct? The bond angle is what? The bond angle is 120. If we come to sp3, correct? sp3, again, different bond angles. If we come to H2O, the bond angle is different. If we come to NH3, the bond angle is different. If we come to CH4, the bond angle is different. Here you see the normally when we consider the overall geometry is definitely tetrahedral, correct? Overall geometry is definitely tetrahedral. Here you will find 109.28, correct? Here you will find it very close to 107. Here you will find it very close to 104, correct? So this is how exactly the bond angles goes on, correct? So this is the bond angles, how it goes on. Now, I'm speaking about what here? I'm speaking about the bond angle. So this is exactly how they are. Okay. Now, if we next come to the Sp3 D hybridization, So what is the Sp3? I'm just going to remove all these things. Okay, what I have written here. So if we go to the Sp3 D hybridization, okay. So we are now speaking about what? We are now speaking about, okay, first we'll go to one by one. Okay, so you have what here? You have the Sp3 D hybridization. Okay, so if we have an Sp3D or even the Dsp3 hybridization. So what is the structure here? The structure for the Dsp3. Okay, the structure for the Dsp3. So let me say I'm randomly going to select an atom. So let me say some atom is over here in the center. Then you have one here, one over here, one over here, and one over here, and let me say one over here. Okay, so try to imagine the structure in what? Try to imagine the structure in 3 dimensions. So what it is going to happen now? Sp3D, it is going to give you a square pyramidal structure, correct? So it is going to produce you a square pyramidal structure. Now, when you see the square pyramidal structure, okay, So when you see the square pyramidal structure, how many 90-degree angles you are going to find? That is the most important thing. So how many 90-degree angles you find here? So check the number of 90 degrees angle. You will find here 1, you will find here 2, you will find here 3, and you are going to find here 4. Correct? So bond pair, 90 degrees. Correct? So if you check the 90-degree bond angles, how many are there? Just make a note of it first. Okay, how many bond pairs? Now let us go to Sp3 D2. Okay, I've left it to you how many 90-degree bond pairs are there. Okay, bond pair angles are there. Okay. Now let us go to the next one. The next one is what? Sp3 D2 hybridization. Now when you go to Sp3 D2 hybridization, so here what we understood, here the geometry is square pyramidal. So please make a note of it. So here the geometry is what? It is square pyramidal. Okay, let us go to Sp3 D2. Sp3 D2 is what? Sp3 D2 is octahedral. Correct? So if I keep the atom in the center and one atom on top, another atom on top, and then at the angles over here, so making it an octahedral geometry. Okay, so what exactly is going to happen? So here we understand, if we try to connect this one, so this is how exactly it will be from the central atom. Yes, so this is exactly how the structure is going to be. Okay, so this is your what? This is my octahedral geometry. So let me again connect it over here. Okay, so if I try to connect it, yes. So I'm just going to connect the top part. Okay, I have just connected the top part. So now check how many 90-degree bond pairs are there. Bond pair angles. Okay, that is very, very important. You'll find on top. Okay, whatever writing is on top now. You will find 1, you're going to find 2, you're going to find 3, then you'll also find 4. Okay, so only with respect to top, okay, 90 degrees, and again let us not forget the bottom part. Bottom 90 degrees also you need to find. Correct? So even if you find the bottom 90 degrees over here, okay, let me say this is your 1, then 2, and then the third one, and then the fourth one. Okay, so how many are there? Bottom 90 degrees. So here I understand there are 4. Here I understand there are 4. Here also I understand there are how many? There are, let me say, 4. Correct? Dsp2 hybridization, if we move on towards the Dsp2 hybridization. Okay, if we move on towards the Dsp2 hybridization, so this is my central atom, then we have an atom over here, then we have an atom over here, then we have an atom over here, then let me say we have an atom over here. So which geometry it is going to give me? It is going to give me a square planar. Correct? It is going to give me a square planar geometry. So what is the question? The maximum number of 90-degree angles between bond pair of electrons is observed. 90-degree angles is what we are speaking about, correct? So when you find the 90 degrees, the most number of 90 degrees, you are going to find it in which structure? The most number of 90 degrees, you are going to find it in Sp3 D2 hybridization. Most number of 90 degrees, you're going to find it where? You're going to find it in Sp3 D2. Sp3 D2. Sp3 D2. Good evening. Right, let us go to the next question. Okay, so I'm going to select some of the nice questions. Yeah, so here we find a different question. Which of the following is isostructural with carbon dioxide? Which of the structure is, which of the following is isostructural? As I've told you already in the last class, that iso is a representation of what? Iso is a representation of a same. Then structure, we are speaking about what? We are speaking about the geometry. I mean to say structure. Okay, or simply you can say we are speaking about what? We are speaking about the similar geometry here. Okay, same geometry. Now, when we say carbon dioxide, C double bond O and C double bond O, I clearly understand it is having 180-degree Sp hybridization linear molecule. Sp hybridization linear geometry molecule, correct? So this is the structure of what? Structure of the CO2. Now we need to understand that the molecules which are given here, N2o, NO2, N2o5 and NO. Okay, what are their geometry? Let us try to understand one by one. When you go to the NO structure, the NO is like this. Double bond oxygen, you have a lone pair, single pair, then you have a lone pair over here. Okay, lone pair and a lone pair. So this is your NO structure. Okay, this is your NO structure. What is N2o5 structure? One by one. Oxides of nitrogen are very, very important, not only with respect to this question. When you go to the 12th standard P block elements, oxides of nitrogen is very, very important. Regularly, you will find the questions in your competitive exams. Okay, so what is the N2o5 structure? Nitrogen sits over here. So I'm just writing the N2o5 structure. Nitrogen sits over here, double bond oxygen, coordinate bond oxygen, then you have an oxygen linked over here, then the nitrogen, double bond oxygen, then you have a coordinate bond oxygen over here. Okay, so this is your N2o5 structure. N2o5 structure. Now let us move on towards the NO2 structure. NO2 structure. Now, can anyone give me what is the NO2 structure? 30 seconds is what you have. NO2 structure. Please try to give me the NO2 structure. NO2 geometry. NO2. Okay. Now, when you check the NO2 structure, nitrogen, then you have a double bond oxygen over here. Then you have an oxygen also over here. So this is what, this is my NO2 structure. Please make a point. NO2 structure. So normally we represent it as what we normally represent it. Normally we represent it using a negative charge over here. Then you have a double bond over here with a bond angle of very close to 115 degree. Okay, bond angle is very, very close to 115. Okay, so this is what, this is the NO2 structure. Finally, we are having what? Finally, we are having N2o structure, which is again, as I told you, they all are very, very, very important. The N2o structure, N2o, nitrogen, triple bond nitrogen, single bond oxygen with a negative charge. Here, nitrogen with a positive charge. So this is the structure. This is, let us not forget there are lone pair of electrons here. Okay. Now, check the geometry over here. Here, as I've already told you, it is slightly bent structure there. Okay, slightly bent structure. Here you will find the hybridization of the nitrogen. Okay, here the hybridization of nitrogen. See here, this is your sigma, then you have a pi, then you have a sigma, then you have a sigma. Correct? The hybridization is sp2, so it is going to have a trigonal structure. Correct? It is going to have a trigonal structure. But in case of N2o, you can clearly see that the bond angle is how much here? The bond angle is 180. Correct? The bond angle is 180 degree. Hence, it is giving me what? Hence, it is giving me a linear geometry molecule. A linear geometry molecule. So bond angle 180 degree, a linear geometry molecule. Hence, this guy has to be isostructural with what? This guy has to be isostructural with CO2. Isostructural with CO2. Please make a note of it. Isostructural with CO2. Isostructural with CO2. Okay. Hope there's no doubt. Isostructural with CO2. Right. Let us move on to the next question. Okay. Selectively, I'm going to go through the few questions selectively. Okay. Right. Check the next question. The species having bond angles 120 degree. Okay. The species having bond angle 120 degree. Again, a very important question. Species having bond angle 120 degree. Okay. So what is the simple way of solving this? First thing is find out the hybridization of each and every molecule. Correct. Find out the hybridization, because when you check the NCl3 molecule, so I understand Cl is over here, then one more Cl is over here, then one more Cl is over here, then you have a lone pair of electrons. So here I understand the hybridization is sp3. Phosphorus belong to the nitrogen family only. So phosphorus, then you have an hydrogen, then you have an hydrogen, then you have an hydrogen, then with the lone pair of electrons. Again, the hybridization is going to what? Sp3. So I understand the geometry of these guys are what? The geometry of these guys are pyramidal, correct? The geometry of these guys are pyramidal, and we also understand what is the bond angle. When we say pyramidal, we also understand what is the bond angle. Okay. Now, when we go to the Clf3 structure, when we go to the Clf3 structure, Clf3, check the Clf3 structure, what we have done. When we go to Clf3 structure, we understand that Cl is in the center, then you have a fluorine atom over here, then you have a fluorine atom over here, then you have a fluorine atom over here, then there is a lone pair, then there is a lone pair, correct? Then there is a lone pair. Okay. So what do I find here? Between the atoms, the bond angle is how much? The bond angle is 90 degrees, correct? Between the atoms. So here also you will find how much? Here also you will find there's a 90-degree bond angle, correct? Because you have to imagine the structure in a 3-dimension, correct? Here you will find that these guys are your axial bond, and here you will find this guy is what? This guy is your equatorial bond. So between the equatorial and the axial, the bond angle is what? The bond angle is 90 degree. Okay. So here is the equatorial bond. So the remaining structure is what now? The Bcl3 structure. Now we understand the Bcl3 hybridization. See, hybridization plays a very important role. Here it is Sp3, here it is Sp3. Here what is going to happen? So let me say this is my S, P, P, and here it is P, and let me say this is B. So the hybridization is going to be what? Sp3 D hybridization. Okay, right. Let us go to the Bcl3 molecule. If we go to Bcl3 molecule, one Cl is linked over here, one more Cl is linked over here, correct? So this is going to give me what, which kind of hybridization now? If I say S here, this is my P and this is my P, the hybridization is going to be what? The hybridization is going to be Sp2, and I understand the structure is what? The structure is trigonal planar structure, correct? It's going to be trigonal planar geometry. And I have already given you, if we have a trigonal planar geometry, the bond angle is going to be how much? The bond angle is going to be 120 degree between the atoms. So which the species having bond angles of 120 degree is how much? 120 is Bcl3. And you can also see the question, which year it had come. Okay, Bcl3. Bcl3 bond angle is 120 degree. Bond angle is 120 degree. Right. Let us move on to the next question. One by one, we are going to move on to the questions. Okay. Right. Check this question now. Check this question and try to answer this question. In which of the following molecules, again, I think I had given you a very similar set of questions, right? In which of the following molecules all bonds are not equal? Now try this question. In which of the following molecules all bonds are not equal? Again, I'm going to give you how many seconds here? 30 seconds. So you have 30 seconds to solve this question. 30 seconds is what you have. Start solving the question. 30 seconds is what you're having. Yes. Hi everyone. Hope you people are getting or understanding how to solve these questions. Please, you can share this class with any of your friends. Right. So what is the most simple thing? Already we discussed NF3, right? NF3 is having an hybridization of how much? Hybridization is Sp3. BF3 hybridization is what? Sp2. Clf3 was Sp3 D hybridization. AlF3, correct? AlF3. So if you check the hybridization, here, so atomic number is how much? 13, correct? Then you have a neon over here, then you have a 3s2, then you have a 3p1. So this is what? This is ground state configuration. Excited state configuration will be 3s1 and 3p2, correct? 3s1 and 3p2. So here it is going to be a single electron, then you have 2 electrons over here. Check how do I solve it? Okay, check here, how do I solve it? So what exactly is happening now? Here I can attach one fluoride, fluorine atom, here also one fluorine atom, here also one fluorine atom. So check which are the orbitals which are involved. There is one 3s orbital and two 3p orbital, correct? So the hybridization is going to be what again here? You will find the hybridization is again sp2, correct? So with respect to sp2 molecules and with respect to sp3, okay? So here I understand with respect to nf3, it is pyramidal structure, correct? It's a pyramidal structure, so all bond angles are going to be equal. With respect to sp3 here, I mean sp2, with respect to sp2 over here, okay, with respect to sp2, here it is going to be what? Here it is going to be trigonal geometry, correct? Here it is going to be trigonal geometry. Read the question. What is the question? The question they are asking is, all the bonds are not equal, correct? In which of the following molecules all the bonds are not equal? So when we go to Clf3 structure, I had just drawn the Clf3 structure. Here you will find a fluoride. Here also you will find a fluorine atom. Then here you will find a fluorine atom. Then here you are having a lone pair. Then here also you are having a lone pair. The hybridization is what? Sp3 D hybridization. Sp3 D hybridization, correct? So what do we clearly see here? If I write the structure over here, I have to always write elongating which bond? Elongating the axial bonds. Elongating the axial bonds. Let us not forget, these are what? These are your equatorial bonds. These are equatorial bonds, axial bonds and equatorial bonds. And we have already understood that when we compare the axial bonds, axial bonds are longer compared to which bonds? Compared to the equatorial bonds. Correct? They are longer compared to the equatorial bonds. So what do I understand here? That in Clf3 molecule, the axial bonds are not equal to equatorial bonds. Okay, the axial bonds AB are not equal to equatorial bonds, not equal, because axial bonds are longer compared to which bonds? Longer compared to the equatorial bonds. So the answer has to be what here? The answer has to be the Clf3 structure. Please make a note of it. The answer has to be the Clf3 structure. Okay, please make a note. I'll give you 30 seconds to write down the things. Clf3 structure. Right, let us move on to the next question. Right, interesting question. The hybridization of atomic orbitals of nitrogen, the hybridizations of atomic orbitals of nitrogen in, look at those structures, what I mean, the molecules, what they have given, NO2 plus, NO3 minus, and NH4 plus respectively are. NO2 plus, NO3 minus, and NH4 plus respectively are. Okay, so you have 30 seconds to solve it. 30 seconds and your time starts now. It is very important that you know the structure of these molecules. Okay, without knowing the structure, it is going to be a very, very difficult task to solve. Right, let us try to understand now. Normally, there is a confusion between an NO2 molecule. Listen to me carefully. Normally, there is a confusion between what? There's a confusion between the NO2 molecule and the NO2 plus molecule. Okay, NO2 and NO2 plus. So remember one point, NO2 is definitely bent structure. We have just done this one, right? NO2 is definitely bent structure. with a bond angle of somewhere very close to 115. Okay, 115. But in case of NO2 plus, due to removal of electron, okay, due to removal of electron, okay, the molecule becomes linear. So please make a note of it. Due to removal of the electron, the molecule becomes what? The molecule becomes, or I can say due to the loss of electron. It's not like, you should not say removal of electron. Let us use the word that it is due to the loss of the electron. Okay, so due to the loss of the electron, the molecule has become what now? The molecule has become linear, and the hybridization. So we understand what is the geometry of hybridization, right? I mean, this particular geometry hybridization. So it is going to be what here? It is going to be Sp hybridization. Okay, so please make a note of it. It is Sp hybridization. Sp hybridization. Okay, so how do I write the structure? How do I check the structure here? Nitrogen, double bond oxygen, double bond oxygen. Okay, so lone pair, lone pair, lone pair, and here also you'll find lone pair, lone pair, lone pair. Nitrogen has made 4 bonds, so the whole molecule is going to have what? The whole molecule is going to have a positive charge. Okay, positive charge. So I clearly understand that here you find as a sigma, then you have a pi, then here you find a sigma, and here you have a pi. Okay, so how many sigma bonds are there? 2 sigma bonds. So hybridization, I clearly understand that it is Sp hybridization. So please make a note of it. Sp hybridization. Sp hybridization. Sp hybridization. Okay, now let us move on to the next structure, the NO3 minus structure. Nitrogen, double bond oxygen, coordinate bond oxygen, then oxygen with a negative charge. This is my NO3 minus structure. N with 3 oxygens, okay, N with 3 oxygens, and with a negative charge on the oxygen. Okay, so now if I say this is my sigma, if I say this is my pi, my sigma and my sigma, how many sigma bonds do you find? 3 sigma bonds. So the hybridization is going to be what? Sp2 hybridization. So I understand my NO2 plus is Sp, NO3 minus is Sp2, remaining one is what? Remaining one is NH4, correct? So NH4, because the nitrogen has made the 4th bond over here, so hydrogen, and here also hydrogen, here also hydrogen, then there is a positive charge on this particular complex. Check how many sigma bonds, 1, 2, 3, and the 4th one. So hybridization is going to be what? It is Sp3 hybridization. Okay, so NO2 plus is Sp, NO3 minus is Sp2, NH4 plus is Sp3. Sp, Sp2 and Sp3 hybridization. Sp, Sp2 and Sp3 hybridization. Sp, Sp2 and Sp3 hybridization. Here you can also take a question. What will be the hybridization of NO2 molecule? Because again, as I told you, these molecules are very, very important. So they keep on asking. Oxides of nitrogen are very, very important. So you have to keep on practicing them. Okay. So the hybridization. Okay. So the question is, what will be the hybridization of this molecule? Okay, I've already given you the structure. It's a bent structure. NO2 plus is what? NO2 plus is a linear molecule. Okay, so here only you can add one more homework point. The homework point here itself I'm going to give you is, if you have an NO2, let me say negative molecule, NO3 minus we have practiced. So what if we have an NO2 minus molecule? Okay, what if there is an NO2 minus molecule? What will be its geometry and what will be its hybridization? So that you can take it as what? You can take it as a homework. NO2 minus and NO2 minus geometry and its hybridization. Geometry and its hybridization. Okay, right. Let us move on to the next one. NEET 2000. So here it was NEET 2, NEET second phase 2016, and here we are going to discuss the NEET 2013 question. See, there are nice, interesting molecules over here. You will find there is an SpCl3, BaCl2, TeF2, and ICl2 minus molecule. You are supposed to find out xenon difluoride or XeF2 is isostructural with which of the molecules? Isostructural with which of the molecules? Okay. And as usual, I'm going to give you 30-40 seconds of time. Start solving them, and your time starts now. Your time starts now. Your time starts now. Now again, it is very important that we first find out the Xcf2 hybridization, or first know the Xcf2 hybridization over here. Okay, so for that we should be knowing what? We should be knowing the Levi-Strauss structure, and then I come to understand that how many fluorides are attached. One fluoride you will find here, one fluoride you will find here. Okay, so how many lone pair of electrons do I find here now? 1, 2, combined together 3. So I understand there are 3 lone pair of electrons. So I'm going to make those electrons, I'm going to write them here. So let me say there's one lone pair of electrons here, and let me say there's another lone pair of electron over here. So this is my another lone pair of electron. Then there's another lone pair of electron. Correct. So if I want to find out the hybridization in this case, if I want to find out the hybridization, so if I say this is my S, and if I say this is my P, lone pair of electrons, here it is going to be P, another P, and the D. So hybridization is going to what? Hybridization is going to be Sp3 D hybridization. Correct. What is the overall geometry over here? Overall geometry is trigonal bipyramidal structure. Correct. So the overall geometry is trigonal bipyramidal structure. Now, check where exactly are the fluoride molecules. Correct. Both the fluoride molecules have occupied the axial positions. Correct. Both of them, they have occupied the axial positions. Now you need to find out in the following molecules, SbCl3, BaCl2, ICl2 minus, and TeF2, where do you find the positions are, the atoms are positioned at what? The atoms are positioned at axial bonds or axial position. So where do you find? Now let us try to understand first the ICl2 minus molecule. Okay. Now, if you take an ICl2 molecule, when you take an I in the center, so you have a lone pair of electrons over here, lone pair of electrons. So let me say the lone pair of electrons, and there's one single electron. Let us not forget. So I'm going to keep it over here. Okay. So what I'm going to do, I'm going to, let me say, extend one fluoride over here. Chloride, it's chloride. And let me say one chloride over here. Okay. So I'm just going to write it neat. Give me just 1 minute. So let me say now using one electron each. So one electron, then you have a Cl, and then again you have a Cl over here. Okay. What is the negative charge indicating? Negative charge over here indicates extra electron, correct? Negative charge indicates that there is an extra electron. That means the single electron, I'm going to pair it with an extra electron. So you will see now how many lone pairs do you find here? You will find there are 3 lone pairs. So let me say this is your one lone pair. Let me say here is your another lone pair, and let me say here is your another lone pair. Okay, so lone pairs is what you see over there. Lone pairs. So again, what is its hybridization? If you say this is your S, and then you say P here, and the P here, and the D here. So again, the hybridization is going to be what? It is going to be Sp3 D hybridization, correct? The hybridization is Sp3 D hybridization. Okay, Sp3 D hybridization. So clearly understand that the chloride molecules over here, they have occupied which position? They have occupied the axial positions. They have occupied the axial positions. So hence it is clear that when you consider the Xcf2 molecule, Xcf2 is isostructural. It is isostructural with which molecule? With ICl2 negative molecule. ICl2 negative molecule. Isostructural with ICl2 negative molecule. ICl2 negative. ICl2 negative. Okay. Right. Let us go to the next question. There was also one interesting question here. Okay. Just give me 1 minute. There's also one interesting question. Right. Try to solve this question. You have 60 seconds to solve this question. 60 seconds to solve this question. And your time starts now. 60 seconds is what you're having. Your time has started. $60 is what you're having. Some of the properties of the two species, NO3 minus and H3O plus, are described below. Which one of them is correct is the question. Which one of them is correct? Which one of them is correct? You need to find. So how do you solve this one? Okay. So now we have been discussing, right? We have been discussing with respect to the NO3 minus molecule, correct? So you find that nitrogen is here, double bond oxygen, then you have a coordinate bond oxygen, then you have a single bond oxygen with a negative charge, correct? Similarly, if I want to write the H3O plus, okay. So how do I write here now? Oxygen in the center. So initially, if I want to write the water molecule, so let me say this is my water molecule. Check this one. So let me say this is my water molecule, correct? This is my water molecule with the hybridization as what? Hybridization is Sp3. And here you will find, because of the pi bond and the sigma bond, sigma and a sigma, the hybridization is what? Hybridization is Sp2. Okay. So hybridization, one thing is for sure, hybridization is different. Now, thing is what here, it's an H3O plus molecule, correct? It's an H3O plus molecule. That means using the lone pair of electrons, it has made one extra bond with the hydrogen. Okay. Using the lone pair of electrons, it has made one extra bond with the hydrogen, correct? So that is the reason why it has become what? It has become H3O plus molecule, correct? It has become H3O plus. So let me say I'm going to write the structure here, H3O plus structure. Okay. So if I want to write the H3O plus structure, so how do I write here now? Here it is an oxygen over here. Okay. Then there is a hydrogen. Because of the use of the lone pair, one hydrogen has come here, one more hydrogen has come over here. Then with the lone pair, it is sitting over here. So this is what? With the positive charge. Okay, there's a positive charge. So this is my H3O plus. So looking at the structure, it has now become very similar to what? It has become very similar to NH3 molecule, correct? So I clearly understand this has occupied which structure? It has occupied the pyramidal structure here. Correct? It has occupied the pyramidal structure, and this I understand it is trigonal planar structure. Trigonal planar structure. Pyramidal structure and trigonal planar structure. So what do I understand now? Hybridization is definitely different, because in case of NO3 minus it is Sp2, in case of H3O plus it is Sp3. Hybridization is definitely different. It is just not the hybridization which is different, even the structure is different. What is the structure? In case of NO3 minus, it is trigonal planar, and in case of H3O plus, it is pyramidal structure. Okay. I'm speaking about the geometry of the molecule. The geometry of the molecule is what? Pyramidal structure. And hence, what happens here now? Hybridization is not same. Neither the structure with respect to the central atom. Okay. Neither the structure with respect to the central atom. Neither the structure with respect to central atom. Right then, guys. Have any doubts? Please ask me, or else we are going to stop the class. Thank you so much.